Okay. What I'm doing now is there's the induced pickup generator coil around the motor coil on the top, and there's one on the bottom. And in the past videos I used a single diode, a pretty big diode. But now I'm using little diodes, and it's working a lot better. Where's the camera here? And I've doubled them up. Romero UK did this in his looper. So I make a full wave bridge, but you put 2 diodes instead of just one. Double it up. You see a full wave bridge, red, positive, negative. Here's the AC coming in. I did green. So I have a full wave bridge rectifier across the top one, and I got another full wave bridge rectifier right here across the bottom coil, the coil beneath. You can't see right now. And I'm going into a 47 UF cap. And what I'm going to do is a resistive load on this, because that's how you're supposed to check power. So I'm doing that. And for the resistive load, I'm using a coil I have. It's the same as these coils in here, and the pickup wind here is 53 ohms. So that's my resistive load, is running the power made from the full wave bridge rectifier from the induced generator coil through this as a load. And so that's my load. Now let's do I just did this, and I got 0.7 volts with the load, and also at the same time 40 milliamps into it. So that's about 0.28 watts I get out of one of these. I got 2 of them, so it's about 0.56 watts, around there. And first thing I'll do is I want to show you how quickly it fills up. This might not be the best way to take power out. It's just slap a resistive load on it. It might be better to fill up the cap and then unload the cap like every half second or second, because can you see this here? This is the top one here, and here's how fast it goes up and how high it goes up. 70, 82, 87, 99, 102, 111, 120, 125, and I'm going to short out the cap now. So you see it goes up pretty quick, but when you put a resistive load on it, now it just kind of bogs it all down to like less than a volt. But that's the way it works. But I got 40 milliamps. So let's put the resistive load on here and show you that I'm not kidding. Okay, resistive load is on this now. Here's my ammeter, and I'm coming from the positive of the full wave bridge into the positive side of the cap. So I'm going in line DC into the cap, which has the resistive load on it. There's the 40 milliamps. Pretty consistent. The motor's not really bogging down. Maybe slightly. That's the good part, is when you put a resistive load on it, it doesn't kill it. So, let's put this back on and see what the voltage is. .7, what that's saying. Okay, the other one's just the same, so I won't bore you with that. The input right now is 15 volts and about 100 milliamps, and it's going about 2,000 RPM, about 2,100 actually. So that's what I'm getting with a resistive load across the generator coils. Like I said, it kind of kills everything when you just put a direct resistive load on something like this. So it might be better to have it pile up in a cap first, then let loose the cap. And then you can calculate watts on how much the voltage drops, how big the cap is, and how many times a second you do it. Anyways, so I just wanted to show that. I'm getting much better results with these small diodes. I think they're IN04s, IN40, very common little diodes. So, okay, that's about all. Okay, thanks for watching.